Hello everybody. Today we will continue the project practice for the clustering and segmentation section. Let us take a minute to remember what did we do last week. Remember the practice details. We have a company that are trying to expand internationally, and the company wants to find out which countries are similar to the United States, similar in economic, demographic, education, and environment. So our job is to build a clustering model to see which countries are similar to the United States. So last week, we cleaned the data set according to the criteria in the project practice. And we used the principal component tool to reduce the number of variables we have. I remember we reduced about 50 variables only to 7 or 8. So last week we get a cleaned and smaller data set that ready to be used to build a clustering model. Today we will see how to find the best number of clusters to be used, how to build a cluster or clustering model, and how to check our result by visualizing our result by using Tableau. So the first step today is to figure out the best number of clusters and the best option or method to be used. This is the clean data set we created last week. So we can do that by using K-centroid. Let me see. K-centroid's diagnostic. So I'm gonna add this tool. I'm gonna select all the available variables. I'm gonna check this option. It's always recommended to use this option when you have your data on different scale. And I believe we have this case in our data set. Also, we have three methods or three options here. The one we talked about a few seconds ago. We have k-means, k-medians, and neural gas. We're gonna try all of them and choose the best option for us. So the range of clusters between 4 and 8. I'm gonna leave the rest of options as it is. And browse tool. And I'm gonna save the report outside Alteryx in order to compare the three methods. So I'm gonna add render tool. I've already created Excel file for this one, so I'm gonna just select the file I created, Excel, okay. So k-means for this one, okay. Now I'm gonna simply copy paste this and choose k-medians here, and I can choose another file, Excel, k-medians, okay. Oh, come on, guys. The last one, neural gas, same thing. Okay. So Excel, okay. So just let me check before running the workflow. It's gonna take a few minutes for this workflow. So just to make sure everything is okay. So k-means, k-medians, and neural gas. Okay. I believe we're good. So let me run this. So this is going to take few minutes. Remember, we selected all the available variables, but you can try different combination of variables to get the best result. Anyhow, if you use the principal component tool to reduce your variables, you cannot escape the first variable you created because remember the first variable explained the most part of the variance between the variables. So you cannot escape or deselect the first variable you created by using principal component tool or by using PCA method. Also, let me show you this template. So I created this template to compare the result for the three methods. So we will use this summary. We're gonna get the first, third quartile, and median for each method, and we're gonna calculate the interquartile range to see which one is the best method to use to build a clustering model. Okay, still running. A few more seconds, I think. So in each report, we're gonna get two tables, each table for one index. The first one is the, I don't remember the name, the RAND index and the CH index. We're gonna check both of them, and we're gonna have whisker plots for each index also. We're gonna choose the highest median to choose the number of clusters to be used. Oh my God, still running. Okay, I believe we're done. So this is the first report, which the k-means method. As I said before, we have two tables. Each one gives us information about one index. The first one is the adjusted RAND index. We can see the value of the first quartile, third quartile, median, mean, and the minimum and maximum. The same thing for the CH index. Also, we have the whisker plot for both indexes. Okay, now to find the best number of clusters to be used, we should look at the highest value for median. So in our case, we can see that the 4 clusters has the highest median here for both indexes, over here and over here. So if we check the other two methods, let me see the k-medians. Okay, 4. We can say 4. Here we can choose 4 or 5, but for the CH, 4 is far better than 5. Okay, how about the neural gas? Again, pretty much same result. So it's clear that 4 clusters is the optimal number for our model. But now we need to know which method is the best to use. So the best way to find out is to check the highest median for each method and the smallest interquartile range over here. This is the range, the interquartile range. So that's why we save the numbers of each method so we can compare it. Okay, let me do it in Excel real quick. So I'm gonna open the three files. So we choose to go with 4 clusters. So I need only these numbers. I'm gonna take the first, median, and third. This is the neural gas. So I'm gonna add round over here. So 1920, yep, we're good. So the k-means and finally we're gonna check which one? This one the k-means, I made a mistake. So this one over here. And the k-medians, this one, okay. So we're gonna have it like this. First, median, and third quartile. So interquartile range is the third minus the first. So it's pretty simple. So let's check the median. 51, 19, 59. We can, okay, let me do it like this. Oops. We need to, that's okay. So if we check the median, the k-median and the neural gas has the best medians. We have 20 here, here we have 19.8, 60, 59. So both medians are very good. So I'm talking about the CH and the RAN. So if we check the interquartile range, we can see the neural gas has better range or smaller range, especially for the CH method. So I'm gonna go with the neural gas as the best method to use in our modeling. Can you see the difference here? It's almost twice. Here it's the same. So the same, almost the same median, but better interquartile range. So I'm gonna go with the neural gas. So the next step, let's go back to Ultrix. The next step is to build a cluster model or a clustering model. We can do that by using, we have, let me see, Centroid cluster analysis tool. Oh my God, it's a very long name. Anyhow, okay, cluster model. Again, I'm gonna choose all the available variables here. Standardized the field again. And I'm gonna go with the neural gas number of cluster as we said, it shows 4. So this is straightforward. Once you figure out the number of clusters you need to use and the best method, it's straightforward. So I'm gonna add a browse tool after report. And let me run it. Now we have our report for our clustering model. We have 4 clusters. We can know how many countries or how many data points in each cluster. In our case, we're talking countries. So we have 64, 25, 39, 34. We don't have abnormal number like very low number or very high number. So we don't have like outliers here. So we're good. We have the average distance within each cluster, max distance within each cluster, and the separation. It's the, I think this is the minimum distance between the cluster and the nearest value outside the cluster or nearest data point. So we can get all this information. This is really not helpful. Anyhow, now we have our model. Now, in order to know the cluster number for each data point, each record, or each country in our case, we need to use something similar to the score tool. We use it with the other predictive models like logistic regression and linear regression. Remember that tool? But here, we need to do it to the original data set. So we can use a bent cluster tool, this one. This is, again, this is very similar to the score tool. So one input from the model and the other from the data set to predict the cluster for each country. I'm going to leave it as cluster, and I'm going to add browse after. I don't need actually to add browse here. Anyway, so now we have our data set, and at the end we have cluster field. We have 4 clusters, so we assigned each country to one cluster. Okay, let me check again. Let me add select tool over here. I don't need all this. Deselect all. Just give me country code, country name, and cluster, and let me sort this. I'm just trying to visualize my results, so just like this. I don't need this one also. So see, I have 144 countries, each one assigned to one cluster. We're interested in the United States cluster, so let me see. Oops, can you see the United States? You know what? We can visualize our result to check where in which cluster United States belong to. So again, now I have my data ready to visualize. The last step for this project or project practice is to check if our clustering result makes sense. Or we can say the last step is the validation step. We don't have any external data to validate our result, and we don't have any other validation data set internally, let's say. So therefore, we will try to visualize the result to see if it makes sense. We're going to use Tableau for that. So uh, I'm gonna save our result over here. Let me add output tool over here. Also, I've already created a file. So result, okay. So let me run it. And let me open Tableau desktop also. Oh, okay, I need to delete this one and run it again. Why I didn't find it? Okay. So let me import the file. So I've created an Excel file result. So uh, you need to notice something here. The data type for the cluster field is numeric, but it should be categorical. So I'm gonna change it from here. And you know what? We can change it also. I'm gonna show you how to change it from the sheet here. So to create a map for the world, we can simply double click on country code. So now we have a map for the world, but we have one circle or data point inside each country. We can change the type of, from here, we can select map. Now we have a better visual. So see these countries in gray or in white are the countries that we removed from our data set last week. Remember due the high number of missing or null values. So the countries in blue are the countries we have in our data set. To group these countries, let me see, by each cluster, we can add another dimension here. We can select, let me see, where is cluster? Okay, as I said, we need it as change the data type or convert to the script. So, or convert to dimension. Okay, I'm gonna add it to color. Now, we have each segment or cluster in one color. See the United States here in orange. United States belong to cluster number 2. That's weird. I couldn't find it in the Alteryx. Anyhow, all the countries in orange belong to the same cluster and are very similar to the United States, given the criteria in the project details. So we can tell the company that the countries that similar to the United States are Canada, Germany. You know what? We can add a country name also here. We can add it to the details. So United States, Canada, we have France, Germany, United Kingdom, Sweden, Norway, Finland, we have Australia, and we have New Zealand. So when we check this visual, actually it makes sense. I believe these countries are very similar to the United States. And if you check the other clusters, you can notice that it makes sense also. So if we want to provide a company with list of countries that's similar to the United States, we can simply go to Alteryx uh, and filter out cluster number 2. So we can get the names of the countries that's similar to the United States. But I couldn't find the United States here. That's weird. United Kingdom. Ah, here it is. Okay. Okay, sorry. Okay, so we're good. So let me give you another example, or let's assume that I want only like 4, 5, or 6 countries that are closest to United States. Let's say the company don't have the financial power or the capacity to expand in like 20 countries. We only need to choose like 5 or 6 countries to start expansion. So let's assume we want only 5 countries that are closest to United States regarding, let me see, let me add another sheet here. So let me choose, I remember we have total tax here. So we have total tax, I'm gonna add it. And I have ATM, let me see. So I'm gonna choose the closest countries regarding total tax rate and ATM totals. So now you can see we only have 1 point because we don't have the third dimension, which is the countries. So I can add country code to the details over here. Now we have 1 point for each country. So we have the countries, we have the tax, total tax, and total ATM. To group by cluster, again, we can use cluster in colors. You know what? Let me switch between them both. Okay. Let me do it again. So total tax. Let me do it here. And ATM. Okay, that's good. So let me add also the country name to the details. So now we're looking for cluster number 2, which contain the United States. So I can simply click on number 2. I can see over here Canada. So this is the United States. If I want to choose the nearest like 4 or 5 countries, I can choose this group. Only this group. So United States, I have Australia, I have United Kingdom, I have Japan, and I have Germany. So I can recommend the company to start expanding in these countries. Also, I can add Canada. It's not very far from United States. So this is another example how to visualize or check your result also. So we're done for today. That's how you create a clustering model. How to choose the best number of clusters, which method to use, and how to validate your cluster by visualizing your data in with Tableau. Sorry. So we're done for today. As always, I'm gonna stop broadcasting and start taking your questions if you have any.